In this video, we will look at several commands that deal with processes in Linux. The first command we're going to look at is the ps. ps is just the command to show processes. Now, by default, if I hit ps, it shows me basically the processes running in this window. It's technically the processes associated with this shell. It's not all that interesting, right? It shows me that I'm running bash and that I ran the ps command. At the time ps was running, the ps command was running. That's essentially what it's telling me. There are a large number of options to PS. You can learn just about everything about a process from this one command. We're just going to look at a handful of options and combinations of options. The first one we're going to look at, if we add two flags, F and U, we don't need to put minuses in front of both of them. We can put them together, and the order doesn't matter either. The F is a formatting option, and the U specifies what user do we want to see? It does matter in this case what order they are in, because the user I'm going to look at is Jeff in the -F format. Now here I can see all the processes that Jeff is running. There's a lot of them. All the processes associated with my GUI are basically what's showing up here. Let's look at just the format of this so we can get the header line. If I do a ps-f, that doesn't show all of my processes. So the first column is the username. Who is the user that's running it? In my case, I said, just show me all the processes for Jeff. The PID and the PPID, every process in Linux has a unique identifier. It's an integer and it's just the next number that's available. It gets given out. The parent process ID, that's the ID of the process that started this one. Every process is started by another process, except for there's essentially one process that is first booted up, and it's called init, and it starts ultimately all other processes. We get told the parent process ID. C is how much CPU is being used. S time is what time did the process start. TTY harkens back to the days when there were terminals. Everything either has a TTY associated with it or is running kind of as part of the system processes. How much CPU time is what the time column is. How much CPU time has this process used? And then finally, what's the command that's being run? ps-fu Jeff, for user Jeff, shows me all of the processes that Jeff is running. If I do ps-ef, the E adds for everything. Show me all the processes. So now you see I have things by Jeff, I have things by root, which are basically the system processes. I have a whole bunch of stuff. This is a huge list of processes. It's every single process that's running on this computer right at this moment. So there's a lot going on this system. The other option I want to show for PS is PS-AUX. You notice I'm getting different information. This is equivalent roughly to the PS-EF. In this case, we don't use arguments. Back in the day, there were basically two different kinds of Unix. There was the AT&T, sort of the corporate, the commercial Unix, and then University of California, Berkeley had their own version of Unix called BSD. So you had the Berkeley Unix and you had the AT&T Unix, and they both had different versions of the PS command. And it just so happened that the Berkeley version did not require a minus sign in front of its arguments, like most Unix commands do. The Linux version of PS honors both of those. If you put a minus sign, it assumes you're using AT&T style arguments. If you don't put a minus sign, it assumes you're using BSD style arguments. So it's just a weird quirk that we happen to have both versions of PS combined into one version. PS-AUX, again, we have a lot of columns shown. So to show what the format is, if I just do the U argument, there we get the headers on the commands. This is, again, the equivalent of the PS, but to show that format. I have a username, I have a PID like we did before. I have percent of CPU and percent of memory being taken by that. The VSE and RSS are the amount of memory being taken. VSC is the virtual size. How large does the program think it is? How much memory does it think it is using? And then the RSS is the resident size. How much memory is it actually using? Linux has the ability to promise a program memory. Yeah, sure, you've got that memory without actually having to give it to it. The resident size is how much memory is actually being used. Then we have the TTY again. The stat is the current status of the process. Ones you'll commonly see are S for sleeping. And when we did the big one, you noticed most processes are sleeping most of the time. R means the process is running. So the PS process was running at the time the PS process was running. Again, we have a start time We have a total amount of CPU time that they've taken, and then what the command was. So that's the PS command. Like I said, there are a lot more options. You could spend literally hours just learning about the PS command. But this is enough to just show you what's going on, get a quick look at what's going on in your system. Another real handy way to get a look at what's going on in your system is with a command called top. And that one is the whole word. We get to use the whole word for our command for once with no arguments. And what this shows me is it's a constantly updating display. It's not just a list that goes out. It's a display in my current screen size that is constantly updating, and it's a very handy way to watch what's happening as it's happening. There are a lot of options within top as well. You can do H to see a lot of them. You can just see, whoa, there's a lot of things here you can do. Don't worry too much about that. The default view is pretty much going to be useful to you most of the time. We can see here in top, we've got some things going on. Whatever's using the most CPU time is going to be at the top. In this case, it's my GUI. Cinnamon is the GUI process that's running. But you still see, if you look up here on the top, I have the uptime information, the same information that we saw in uptime earlier. I see the total number of processes, how much is going on, how much different kinds of CPU time are being used, and you see that the ID is idle, and some information about memory. Top is really handy. You can see the thing that's consuming all your resources is generally going to come to the top in top. To exit top, we just type a Q for quit.